Today we are going to discuss how high reactive metals can be obtained from their compounds. Generally, high reactive metals means they are potassium, sodium, magnesium, aluminum, these are. These metals cannot be obtained from their compounds if we are going to heating with carbon, because carbon cannot be reduced their oxides into respective metals, because these high reactive metals have more affinity to oxygen than carbon. So carbon cannot reduce their oxides into respective metals. Understood? Then how these metals can be obtained from their compound? We have to pass electric current through these compounds. So if we are going to pass current through these compounds, that means molten chloride, so it needs an electrolytic cells, two electrodes, which we will use. One is as cathode and one is as anode. And the electrolyte, that means that we have to use that electrolyte. That is what? The molten chloride of that metal. Which metal we are going to extract? That metal, like that molten chloride, we will use as a electrolyte. So the two electrodes, one is we have to connect with positive end of a battery, and one is we have to connect with negative end of a battery. The positive end, which is connect with the electron, that is called anode, and the negative end of the battery, which we connect with the electrodes, that is called cathode. Okay, now we have to pass current. That means we have to on the switch. If we are going to on the switch, then current will be flow. That means charged particle will start to move. Then the charged particle, positive metal is positive ion. That's why this positive ion will be moved towards the cathode. That means metal will be deposited where? At the cathode. And the chloride, that means chlorine gas, will be stored where? It is stored in the anode, because it is anode means it is positive, and but chlorine gas, it is negative. That's why negative ion will move towards the anode. That means it is attracting by the positive electron. So like this, all the high reactive metals can be obtained from their compounds if we are going to take molten chloride. Understood, students? Then what you have learned today? You have learned that high reactive metal can be obtained from their molten chloride by passing electric current. Then the metal will deposit it where? At the cathode, and chlorine gas will deposit it at the anode. Understood? Then next we are going to discuss refining of metals. The various metals we have obtained from their ores by reduction process. But these metals contain a lot of impurities. So these impurities to be removed. But how these impurities will remove? We have to remove these impurities by electrolytic process. So to remove impurities, electrolyte by electrolytic process, it needs an electrolytic cell, two electrodes, and some amount of electrolyte. So here anode is made up of impure. Suppose we are going to refine metal copper. If we are going to refine metal copper, then the anode is made of impure copper and cathode is made of pure copper. And the electrolyte which we will use, that is also copper sulfate solution. So the two electrodes now we connect with two poles of a battery. Now on the switch, then current will flow. Then when current will flow, at that time some amount of pure copper will deposited at the copper sulfate solution. And from the copper sulfate solution, same amount of pure copper will deposited at the cathode. And this process will continue till the pure copper has not finished at the anode. When pure copper has finished at the anode, then the impurities will settle down at the bottom of the electrolyte, which impurities are called as anode mass. Understood, students? Then some, you see, some metals which we have obtained from their ores, that metals are not in completely pure. That means it contains some amount of impurities. That impurities to be removed, which is called electrolytic refining. That means we have to pass current. So it needs two electrodes. Anode is made up of impure copper, and if we're going to refine the copper, then anode is made up of impure copper, cathode is made up of pure copper, and the which electrolyte we'll use, that is also made up of copper salt. So when current is on, then some amount of pure copper will deposited at the electrolyte, and from the electrolyte same amount of pure copper will deposited at the cathode. Then this process will continue. When pure copper has finished at the anode, the remaining impurities will deposited at the bottom of the electrolytic cell, which is known as anode mud.